HPP market nowadays. So as I mentioned, we have installed over 400 equipment around the world. They are very reliable. And we've seen a tendency that it is growing throughout the years. As you can see, it is exponentially growing. And the compound annual growth rate of the HPP processing has grown for 15.86%. The leader market is North America, owning 46% of it, followed by Europe with a 24%, and then Asia, with its market, which is growing very, very fast because of all the trends of clean label and not very processed, minimal processed, and then the other markets are also growing. So let me talk about the HPP applications, because HPP can be applied to other product types, not only to seafood. The leader one is the juice and beverage one, owning a 24% of the whole market, followed by the meat industry, then the guacamole and avocado products, then the tolling services, which are some companies that own the HPP equipment, and they bring the service of renting the equipment to the people that are interested and the companies that are interested in processing with HPP. And for now, they don't want to buy a machine and they want to rent like that. Also, and then we have the seafood market, which is 7%, and it is growing really, really fast, mainly because of the Shucking applications that you can have with HPP. So when talking about the main applications in seafood, we'll talk in two main. The first one is the Shucking and meat extraction of crustaceans and bivalves. And for this application, we will apply lower pressures from 29K to 50K PSI and lower holding times from 1 to 3 minutes in order to help preserve the freshness, the sensory attributes with HPP, and also help ensure food safety by reducing to safe levels some pertinent pathogens such as norovirus and Vibrio, as well as extend the shelf life. And on the other hand, also for this one, it will help to open instantaneously after processing the bivalves, and also to help perform an 100% of yield of meat extraction in lobsters and crustaceans. So it is very interesting. And on the other hand, I have the application of HPP on cooked seafood or raw seafood products. And for this, HPP will help extend the shelf life and help increase food safety. For this application, high pressures will be applied and longer holding times. Again, this will depend on the type of product that you want to process. Pressure and holding time conditions will vary depending on it. And as I mentioned, there are two main groups. So for the Shucking applications, you can either process lobsters, crabs, mollusks, scallops. There are a lot of applications like this product. And for the other one, of the post-packaging one with raw fish or cooked fish, you have this application such as the raw fish, which is one of our customers, Delpierre. They own one of our machines in Europe. And then we have this other octopus. One of our customers has this too. It's a cooked one. Also, it can be processed raw in order to help tenderize the meat. Also, there's this other application of desalted cod of one of our customers, which is Alcorta. It is located in Spain. They own also our machines, and they process this very interesting product. Then there's this other market for algae. As you can see here, this product is HPP, seaweed salad. It's a Korean product that is commercialized in every Costco in the US. Then you have these value-added products such as fish salads to help increase the shelf life, and they'll be counted and be considered as ready-to-eat meals. Then you have the ready-to-eat meals such as this example of fuchsia, where you have a cooked fish fillet on top of a bed of grains or vegetables that are already cooked. And then we have the crab meat too, which is already cooked, packaged, and processed with HPP. It is very important to take into consideration that for these post-packaging product applications, it is very important to use a very flexible plastic packaging in order to ensure that they would withstand the pressures that will be applied. Okay, so it is very important to the packaging to be mainly made out of plastic. And as you heard before, I mentioned that HPP can help ensure food safety. And the way it does this is by increasing the pressure and by obtaining different inactivations of different target microorganisms. So HPP can help inactivating Salmonella, Listeria, E. coli, even Vibrio, norovirus, also parasites, lower pressures, as you can see in the graph, and as well spoilage microorganisms such as yeast, mold, lactic acid bacteria, and as well as HPP can help meet the food authority regulations. And as you can see, at different pressure levels, different activations are obtained. However, I want to emphasize and a note on this that HPP can't eliminate bacterial spores. So additional controls need to be added in order to address this risk. And now I'll talk deeper into the applications of raw fish and cephalopods products that can be processed with HPP. So HPP can help increase food safety by inactivating, by killing some parasites that could be present, such as this example of Anisakis simplex, which was analyzed on raw arrowtooth flounder. And as you can see, at lower pressures from 207 megapascals to 276 megapascals, which are very low when talking about HPP, you can obtain up to 100% of elimination because of death of these parasites. Because parasites are very complex microorganisms, it is easier to inactivate them with HPP because we will reduce the chemical reactions that will occur because HPP will help the nature, some functional properties, some vital properties of these microorganisms, and this is why we are killing them. Again, these reductions need to be analyzed in a case-by-case basis because for now, these are some results based on raw arrowtooth flounder. But if you want to treat, salmon, different conditions are required. And now HPP can help inactivate vegetative bacteria such as listeria. And as you can see here, I have an example of a fresh catfish fillet. And by increasing the pressure over 600 megapascals for 5 minutes, you can achieve a 5-log reduction of listeria. And on the other hand, I have the mild smoked trout, which you can count as ready to eat because it is already cooked. And in this study, they analyzed the inactivation of listeria and E. coli. And they found out that by combining different parameters, pressure, time, different activation levels could be obtained in this seafood product. So by applying 400 megapascals for 5 minutes, an inactivation of 3 logs was obtained. And HPP here will act as a post-lethal treatment, which is accepted by the FDA. And then, as I mentioned, HPP can help increase the shelf life. And the way it does this is by eliminating, or more like inactivating, spoilage microorganisms that can be present. So, as you know, these spoilage microorganisms, such as the total aerobic counts, are responsible of creating some chiral nitrogen compounds that create the others of flavors that reduce the freshness and acceptability of fresh products. Okay, so as you can see here, I have an example of salmon and cod in which 2 different combinations of pressure and time as a yellow line, 200 bar, 2000 bar for 2 minutes, and as a blue line, 5000 bar for 2 minutes, were applied to these products raw. And when being compared to an unprocessed product, the shelf life was increased for up to 5 days or even more, depending on the pressure or time that was applied to these products. This analysis was performed by storing these products at 0.5 degrees Celsius, is below 3.3, so it was a safe temperature. And as you can see, the spoilage threshold is a red line, so HPP helped increase the shelf life a lot compared to unprocessed samples. And now let me talk about the validation studies, which are very important to take into consideration when wanting to process with HPP, any type of product. So because there are not a lot of regulations that can act over HPP, every producer that performs in HPP processing needs to perform a validation study, which is also known as a microbial challenge, and it is designed by what is called a process authority. So a process authority is someone that is an expert in the field. So for this case, it will need to be someone that is an expert on HPP that can confirm that the conditions that are applied, pressure and holding time, will help ensure food safety to prevent any hazards and any foodborne illnesses to the consumer, right? And this will need to be implemented in the HACCP plan. So to perform this HPP validation study or microbial challenge, 3 main factors are needed to take into consideration. The first one is the formulation properties, where the ingredients and the physicochemical characteristics need to be taken into consideration. The next one is the storage conditions, in which we take into account storage time, which is the shelf life, storage temperature, the packaging time. It is very important to take into consideration that you need to package your products in a 10K oxygen transmission rate or OTR packaging to comply with what the Seafood HACCP FDA asks for, and to also help the growth of spoilage microorganisms to prevent the growth of seaweed. So there is a control that must be added in seafood products. And also, we need to take into consideration the HPP cycle parameters, which will be pressure level and holding time. So now I want to make a step back on the raw fish validation focused on the USA. This will vary between different places. It'll vary in Europe or in Mexico, like it'll be different. But for the USA, this raw fish validation needs to be done in a very specific way. So the FDA has no problem if you commercialize fresh fish fillet products, which need to be stored and commercialized frozen, which are treated with HPP. However, if you want to commercialize them under refrigeration conditions, you need to follow these solutions. So as I mentioned before, HPP can't eliminate bacterial spores. So the main concern for this in seafood products is the C. bot type E bacteria, which produces spores, and additional controls may be added in order to prevent and to address this risk. And in order to prevent that the botulinum toxin doesn't grow when it is commercialized fresh. So again, HPP can help eliminate vegetative bacteria such as Listeria and some deteriorative microorganisms, which can help extend the shelf life of these raw fish products, but for some days. So here I show you three main solutions that you can follow when validating raw fish products. The first one is the addition of preservatives, and they need to have an effect against seaweed growth, and their efficacy here must be validated against seaweed. As the next solution is adding a low pH marinade, a pH that must be acidic, as a control barrier against seaweed's growth, because seaweed won't grow under acidic conditions. And for here, a validation will be required in order to guarantee that the pH is homogeneous all through the product. And finally, as a third solution, which is the no control method, is to carry out a validation study of the HPP process to demonstrate that physical spoilage of the raw fish fillet product precedes non-pyrolytic seaweed growth, and again, the botulinum toxin production in the product. This one is the most complex one. I'll show you how is it done to perform this validation. So first is a pathogen inoculation of the product, where seaweed spores are inoculated into the food matrix. Then the product is packaged in a 10K OTR packaging to ensure food safety with this. And then the second step is the HPP processing, where the product is processed under HPP pressure and holding time to help extend the product shelf life, again, for some days. Then the third step is the shelf life monitoring, where the botulinum toxin is validated to be not present during the expected and extended shelf life that HPP can provide. And in parallel, the product's shelf life will be determined based on organoleptic deterioration of the product, taking into account the total base volatile nitrogen compounds that will be produced. And then finally, we'll get the process validation, where we confirm and we validate that no toxin is formed during the expected shelf life. So you can see in the image, first we need to get the spoiled product and then make sure that the toxin is formed to address this risk. So let me enclose this because I know there's a lot of information on this topic. So the main idea is to carry out a validation study of the process to demonstrate that spoilage of the product will precede the non-pyrolytic seaweed growth and botulinum toxin formation after being analyzed under moderate temperature storage of use of the refrigerated HPP raw fish when being packaged in a 10K OTR packaging. Okay? And now here I show you some commercial examples of some of our customers that own our machines. And they use HPP to help extend shelf life to ensure food safety with our technology. Here you can see Del Pierre, where they process raw fish fillets. Here on the other side, Alcorta, who's a Spanish company that processes desalted cod. So both of these are very interesting. Then we have the cephalopods product. This is a market that is growing a lot. This is a very interesting application. HPP can help texturize the product. For this, different conditions are applied depending on the product you want to process. Again, this is a case-by-case basis. You can either process pre-cooked octopus, raw squid. Also, for the other side, you can process already cooked fish fillet. And now I'll talk about the ready-to-eat seafood market. So the value add of HPP for the ready-to-eat market, when being compared to a common pasteurization process, is that HPP can help increase the nutrient retention, sensory, and quality attributes because it's a non-thermal technology, and again, can help ensure food safety and increase the shelf life. And again, a common thermal treatment such as pasteurization after being pasteurized needs to be chilled. However, HPP just goes out of the machine and everything is done. And here I show you some commercial examples of some of our customers that right now are using HPP as a post-lethal treatment for ready-to-eat products. As you can see here, I show you some commercial examples of one of our customers, Fuchsia, and they cook salmon fish fillets and they place it on top of this rice green bed of it, and they place it on top of a tray, and they perform skin packaging, and this way they sell it. And there are different commercial presentations. Also, you can see some shrimp that are already cooked. This is a market that is growing very fast. And by now, I'm going to show you the new technology that we just launched, which is the HPTP, which stands for High Pressure Thermal Processing. It's a very new technology, and it will help achieve sterility to create low acid shelf stable foods, and will help increase the retention of nutrients and the quality attributes. This is a very new technology, and still we're performing research in this to understand its applications. So this technology is done by using that canister. This is what we call the canister. It is isolated, thermically isolated with different layers, plastic layers. It has a movable piston in order to help pressurize the products that are inside of it. And it is preheated. As you can see here on this diagram, it is how it is done. It is done in these 5 simple steps. The first one is the preheatment of the canister and the product that will be processed. Then, when the product is loaded into the canister, everything already preheated at the same initial temperature, it is loaded into the machine as in a normal HPP process, as I described at the beginning. Then the HPP machine will do its process, increasing the pressure during a certain holding time. Then pressure is released, canisters are unloaded, and it is done. Then the product needs to be cooled because it will come out of the machine at the initial temperature. However, this is a process that combines the lethality in the destruction of heat microorganisms such as spores with the rapidity of high pressure. And this technology is based on what we call the adiabatic effect and the compression heating. As you can see here in this graph, as a blue line, you have the HPTP process, and as a gray dotted line, a conventional one. As you can see here, we start at initial temperature, and then when pressure is applied at the red dot of compression heating, temperature will rise within pressure because of adiabatic heating. Then, when the desired pressure is reached, we hold the holding time, the pressure, during this certain time duration. And then, when the process is finished, we start the decompression cooling, where the pressure drops instantaneously, and within it, temperature. So it is cooled faster. So you can see, compared to a conventional retort processing, the product is exposed to a shorter period of time to heat. This is why it will help, again, preserve the quality sensory attributes of the products. And also the HPP process will have an effect on that too. Again, this technology will help reduce the thermal load and exposure time to which food will be subjected. And here there are some applications. Mainly it will be applied for ready-to-eat meals because of temperature will help cooking it and increase the shelf life and also increase the nutritional quality. So here I show you a steamed soap product. This was a research study where they applied 87 kpsi for 5 minutes as holding time, and they reached under pressure 110 degrees Fahrenheit. And they achieved an inactivation of 4.5 logs per inactivation of non-paralytic seaweed spores. And it was considered as a ready-to-eat shelf-stable food that could be a possibility with HPTP. Again, this isn't validated by the FDA, requires validation by the FDA, but still research is going on how to produce these products as shelf-stable, ready-to-eat ones, because we need to achieve a higher inactivation of seaweed spores. And on the other hand, I show you this other value-added application on yellowfin tuna slices, which is patented by Thai Union. And what they did is by combining pressure and high temperature, they helped texturizing this meat to produce this sliceable seafood product. It's a very interesting one. And now let me go deeper onto the applications of HPP when performing shucking on shellfish and mollusks to help achieve 100% of yield of meat extraction of this. So as you may already know, traditional shucking is a very labor-intensive process, high time consuming. You can guarantee that you will recover 100% of the meat existing in these products. And it is also hazardous because some injuries may occur when performing a manual shucking. In contrast to this, HPP can bring the benefit of helping enable an effortless extraction of this crustacean or oyster's meat without the use of heat, which will help preserve the freshness of the products that are processed, and again, to increase the productivity. So, the way this shucking process is done is very simple. It's, as I mentioned at the beginning, an HPP process. However, for this type of products, you don't need to package them. They are introduced live into the basket. We recommend this so that the product can come out of the machine fresh, even fresher, okay? We will prevent the chemical reactions that occur after a product dies, after a seafood product dies, so it will come fresher. Then, after the live product is loaded into the basket, it is pressurized into the HPP machine, same way as an HPP process, and then it comes out already shucked. So let me go deeper into the applications of HPP when processing oysters. For this, again, we will perform an effortless shucking. The pressure conditions that we'll apply will be lower, from 25 to 2700 bars. And what will happen is that we will help denaturing the proteins that will be present in the abductor muscles of these oysters, which are responsible for keeping the oyster closed. So with this, the oyster will come open, okay? Also, will help ensure food safety by controlling to safe levels Vibrio up to 3.52 log reductions to comply with what the ISSC mentioned in the FDA Seafood Hazard asked for. And also we can eliminate other pertinent pathogen, which will be norovirus. And will help increase the shelf life up to even 21 days. I've seen some cases from 15, 18, 21 days. This needs to be analyzed in a case-by-case basis, but it is really increased without adding any preservatives and under refrigerated conditions. So here I show you the study that was made with Pacific oysters, and they analyzed different combinations of pressure and holding time, and they saw that by combining 275 megapascals for 3 minutes, or by applying 300 megapascals for 2 minutes, a total release of the edible meat from the shell could be obtained. However, by increasing the pressure level, broken shells could be found, or by decreasing the pressure levels, partial release of the meat from the shell could be seen too. So this needs to be analyzed in a case-by-case assessment in order to find the most successful parameters to process your product. As I mentioned before, HPP can help ensure food safety by reducing to safe levels Vibrio to up to 3.52 log and comply with what the ISSC stands for. Okay, so here I show you 8 different research studies where they analyzed the application of HPP on different oyster products, and they saw that by applying lower pressures for shorter holding times, we can not only achieve this reduction, but even surpass it. So as you can see, Vibrio isn't a problem when processing with HPP. Now here I show you some ways in which you can commercialize your already shocked products. First, I have the in-shell one, which is the in-banded oyster. When a rubber band surrounds this oyster to maintain it closed after processing it, and this way, when it comes out of the machine, you have the meat inside the oyster, okay, intact. And you can bring the customer the experience of performing the meat extraction by themselves. So it is a great way to commercialize them. Then I show you the half shell one, where open oysters are placed on a tray and the top shell is removed from it. And then skim packaging plastic material covers this oyster to prevent its moving during commercialization. This is a very attractive commercial format too. As a third option, I have the vacuum packaging one, where the already extracted meat is introduced into a bag, 10K OTR material again, and then is sold that way. And now here's the HPP application for lobster processing. This is very, very interesting one, and many of our customers are already doing this. It's very common by now. And again, HPP can help perform an effortless shucking and recover 100% of the meat from the shells. For this, a little bit higher pressures need to be applied from 2,000 to 4,000 bars to help lose the muscle attached to the shell and extract easier this lobster meat. Again, food safety can be ensured. We're reduced to safe levels up to or over 3.52 log of Vibrio to meet with what the ISSC standards ask for. Here I show you some commercial formats in which you can commercialize, sell your already shocked lobster products. First is the whole or split lobster. It is like very common for culinary clients that want to perform by themselves the shucking, the extraction of the meat from the shell by peeling off the meat, and it is very interesting. Then I show you the raw or cooked knuckle and claw meat. This is one of our customers, Ready Brothers, and they pack their products in a 10K OTR packaging too. Take note of that. And again, they also help bring the customer the experience of extracting the meat from the shell, from peeling it off. And finally, the raw or cooked lobster tails, where you can see here I show you 2 different formats. These are some ideas of how you can commercialize these already HPP products. Then I show you here some of our customers with our machines that are using our hyperbaric HPP machines for shellfish shucking, Ready Seafood, Black Goose, Greenhead Lobster, Complaint Seafood, Riverside, Westmoreland. And now let me go deeper into the HPP equipment, okay? So we have 5 different units. They all work the same, pressurized the same. However, they are differentiated by the throughput that you can have with them. So if you have any questions about prices or some features about these machines, there are my colleagues over there, Anthony and Roberto, and they can help you answer these questions. And finally, as closing remarks, so HPP will help offer and ensure food safety of seafood products. Also, it will help increase shelf life, will help preserving the freshness attributes while also acquiring a clean label of them. And again, for shucking processes, we can obtain 100% of the meat that can be extracted. And with all this, it can help you open new market opportunities. So it is a very versatile technology. And well, Hyperbaric is located all around the world. Our headquarters are located at Burgos, at a very beautiful city, 3 hours north of Madrid. And also we have offices in Miami. We have also other offices in Latin America, in Asia, in Singapore, in Australia. So we're everywhere. And I'm part of the applications team, which are a HPP specialized team. We have 3 PhD members that can bring technical support to anyone that is interested. We can help performing any consulting services on HPP, packaging, product development, perform these validation studies. We can guide you on this depending on your product. Again, this is a very case-by-case basis. And if you have any question about that, you can reach out to us. This is the team. That's our email, apps@hyperbaric.com. So in case you have any technical question, please write us via email. Any one of us can give you support on that. Also, we have what we call the pilot plants and HPP incubators. So are these spaces where we have one of our machines and we bring support to our customers. So they come or they ship us product, we process them with HPP, then we ship them back, or you can see it by first hand. So you can see how HPP works and what HPP can do to your product. We have one pilot plant in Miami, where we are from and where we are established, and another one in Burgos. And also, this food science support, the applications team, lead these pilot plant and HPP incubators by bringing R&D advice, consultancy services, advice on HPP packaging, the processing parameters of HPP. Also, we can help you, we can guide you with the food safety regulations, and within this, to perform validation studies or to understand how HPP can be applied to help increase the shelf life of your products. So thank you. That's all. If you have any questions, please. Yes, please.
You mentioned for shellfish, scallops, and oysters. Have you ever done clams?
Yes, clams work very well. In fact, last week I performed a Shucking process with clams, and it went amazing. Like, it opened very easy, lower pressures well applied, and it worked very well. The meat also extracted easy. Like, it's amazing because it opened, and you like only take it. I had a plate in it, and it just like.
Coastal bay clam?
Sorry?
Was that a coastal bay clam or ocean clam?
It was an ocean clam.
What was the species?
Oh, I don't remember.